Before one can even consider fixing code, the exact problem must be identified and clearly articulated. It is impossible to provide a solution without a comprehensive understanding of the issue at hand. Therefore, the first step in the troubleshooting process involves defining the intended functionality of the code. What specific task is the code designed to perform? What outcome is expected when the code is executed? Without this fundamental understanding, any attempt to fix the code would be akin to blindly poking around in the dark. Once the intended functionality is established, the next step is to pinpoint the discrepancy between the expected behavior and the actual behavior. What is the code actually doing? How does it deviate from the intended outcome? This requires a detailed analysis of the code's execution, including the inputs, outputs, and intermediate steps. It may involve using debugging tools to step through the code line by line and examine the values of variables at different points in time. In describing the problem, it is essential to provide specific details rather than vague generalizations. For example, instead of saying the code doesn't work, one should say the code produces an incorrect result when given a specific input. It is also helpful to provide sample inputs and outputs that demonstrate the problem. This allows others to reproduce the issue and understand its scope. Next, one must examine the error messages or exceptions that the code is generating. These messages often provide valuable clues about the cause of the problem. They may indicate a syntax error, a runtime error, or a logical error. It is important to read these messages carefully and understand their meaning. If the error message is unclear, it may be helpful to search online for more information about the error. Then, the relevant portions of the code must be presented. It is usually not necessary to provide the entire codebase, especially if it is large and complex. Instead, focus on the sections of code that are most likely to be related to the problem. When presenting the code, it is important to format it correctly and use syntax highlighting to improve readability. It is also helpful to add comments to explain the purpose of each section of code. Along with that, one must provide information about the environment in which the code is being executed. This includes the programming language, the compiler or interpreter, the operating system, and any relevant libraries or frameworks. This information is important because the behavior of the code may vary depending on the environment. Once the problem is clearly defined and the relevant information is provided, the next step is to formulate a hypothesis about the cause of the problem. This involves considering the possible reasons why the code is not behaving as expected. It may involve examining the code for common errors, such as typos, incorrect logic, or unhandled exceptions. Once a hypothesis has been formulated, the next step is to test it. This involves modifying the code to see if the problem is resolved. It is important to make small, incremental changes and test the code after each change. This makes it easier to identify the source of the problem and avoid introducing new errors. If the problem is not resolved, it may be necessary to revise the hypothesis and try a different approach. This process of formulating and testing hypotheses may need to be repeated several times before the problem is finally resolved. Another useful technique is to simplify the code as much as possible. This involves removing any unnecessary code and focusing on the core logic that is causing the problem. By simplifying the code, it becomes easier to understand and debug. Another good approach is to break the problem down into smaller, more manageable parts. This involves identifying the individual steps that the code needs to perform and testing each step separately. By breaking down the problem in this way, it becomes easier to isolate the source of the error. Sometimes, the problem may be caused by an external factor, such as a corrupted file or a network outage. In these cases, it is important to rule out these possibilities before spending too much time debugging the code. It is also helpful to consult with other developers or experts who may have experience with similar problems. They may be able to provide valuable insights and suggestions. Remember to use online resources such as forums, documentation, and tutorials. These resources can often provide answers to common questions and solutions to common problems. In addition to these general troubleshooting techniques, There are also some specific techniques that are useful for debugging code in different programming languages. For example, in Java, it is common to use a debugger to step through the code and examine the values of variables. In Python, it is common to use the print statement to output the values of variables at different points in time. And remember, persistence is key. Debugging code can be a challenging and frustrating task, but it is also an essential skill for any programmer. By following these steps and using the right tools and techniques, one can effectively troubleshoot and resolve coding problems.